Hey guys, welcome to this session by Intellipaat. Hadoop is one of the world's most renowned big data tools out there right now. Especially in today's world, there is a huge demand and supply gap where companies are looking for proficient Hadoop developers across the globe. And this video deals with the top Hadoop interview questions that have the highest probability to be asked. So use this as a guide to understand about how you can approach the questions effectively and how you can answer them to the best of your abilities. We will be discussing a lot about modes, distributed cage, HDFS, and a lot more. But then before we begin with this session, make sure to subscribe to the Intellipaat YouTube channel and hit that bell icon so that you never miss any updates from us. And of course, if you're looking for certification programs in Hadoop and big data, make sure to check out the latest offerings from Intellipaat on our website. Well, without further ado, let's begin the class. So coming to the first question on the top Hadoop interview question set, it is what are the differences between Hadoop and Spark? This is a very commonly asked question and it has a very simple answer, to be honest. We'll be comparing three simple points here. One is how storage is handled in Hadoop and Spark, the other one is the processing speed, and the third one is the availability of libraries. So in terms of dedicated storage, Hadoop has its own file system, right? It has its native file system called as the Hadoop file system, while Spark lacks a native file system. Then you're talking about processing speed. Hadoop has an average processing speed when you compare to large amounts of data, because here Spark is really very good at handling large amounts of data without having to do much when you compare it to Hadoop. Coming to the next point, which is libraries, right? So Hadoop has the connection with multiple tools, multiple libraries, and Hadoop is pretty much a big tool. But then when you think about the native availability, where a lot of people depend on it, so Spark provides the Spark core, you have the Spark SQL, Spark Streaming, Spark Graphics, Spark MLlib. So you have all of these libraries that come attached with Spark. While you will have to learn and integrate these new things in case if you want to use all of these with Hadoop as well. So that extra learning curve in terms of Hadoop is required. Coming to question number 2, it states what are the real-time industry applications of Hadoop? Hadoop, as you might know, it is already called as Apache Hadoop. It's one of the world's most famous open source program, especially for the world of distributed computing, where we handle large amounts of data day in and day out. The world generates 2.5 quintillion bytes of data a day, so we needed a solution to handle all of that, and Hadoop does just that. So when you think about the practical applications of Hadoop, all the way from the small scale industries to handling a little bit of the big boys as well. So think about Google, think about Yahoo, think about Facebook. So all of these guys also have a solution for their big data because they are generating a lot of data, right? So everything from managing traffics on the street, handling streaming processing, working on content management, how to archive emails, how to save them, working on fraud detection, which is very important in today's world, fraud prevention, targeted advertising, and guys, you can go on and talk about the applications of Hadoop for a long time, and then make sure to keep your answer concise. Do talk about 2 or 3 points, or if you do know some of the application, then make sure to note at least 5 of it. So with this, we can come to the third question that states, how is Hadoop different from other parallel computing systems? Well, this could very well be the first question through which your interview starts. So Hadoop is actually a distributed file system that lets us, handle a large amount of data, to store it, to work with it on, either local machines, offshore servers, or even on clouds as well. So when you think about it, if your data is stored in multiple places rather than one place, it creates redundancy, yes. But here we have the good amount of redundancy, because if your data crashes, if you tend to lose your data because if one of the nodes stopped working, then your data is still there. So in a distributed manner, you can store data on multiple places. You can use the processing power of multiple machines to actually go on and work with your data. So this does not happen in a relational database, because when you think about it, right? So if you have a relational database, you have to query the database, you have to, pick up all the tables, records, columns, and it'll be a manual task, and you really cannot make use of, multiple machines to do this effectively. It is a good enough method, of course, but at the end of the day, it is not as fast as what Hadoop can do. And of course, Hadoop also provides a scheme where you can build your own column databases, and just for this, we have the Hadoop HBase. HBase
is very similar to SQL, and here we actually go on to run queries on the rows, on the columns, wherever it's required. And basically this is Hadoop's approach to making sure your data storage and access protocols are done easier. And this is how Hadoop is different from the other parallel computing systems out there. Coming to question number 4. Question number 4 is a very important one. It states, what are all the modes that Hadoop can be run in? Well, it's a pretty simple question with a very straightforward answer. Hadoop can be run in 3 modes. One is the standalone mode, the second one is the pseudo-distributed mode, or what we call as the single node cluster, and then we have the fully distributed mode, which is also called as the multi-node cluster. Coming to standalone mode is actually the default mode of Hadoop where it uses the local file system where you're working on for all the input and the output operations. So this is not used popularly in the case of a production environment, but mostly when you're testing or when you're debugging, right? So a standalone mode is very important. One highlight you have to talk about when you talk about standalone mode is that it does not support the usage of a Hadoop file system because it's using the local file system. So make sure to mention that. And then when you're thinking about the pseudo-distributed mode, right? So what happens in pseudo-distributed mode is that you will have to provide 3 files for configuration. There's the core site.xml, you have the HDFS site.xml, and the mapread site.xml, right? So for MapReduce, for core, and for working of HDFS, you have to provide a configuration on which this mode works on. So if you're running on one node, it means that So if you're running pseudo-distributed mode on one single machine, it means that that machine itself is the master and that machine itself is the slave node as well. So this is one thing you have to note. And then coming to the fully distributed mode. Fully distributed mode is of course the production phase of Hadoop where, this is where Hadoop is known to be very powerful, and this is where it beats all the other tools out there. Because here data is used and data is distributed across multiple clusters, multiple nodes. And once you have more than 2 or 3 nodes, we call it a Hadoop cluster. And using clusters, you can have a separate node, which is a master node. You can assign all the other slave nodes as well, and then, work with it in a chain of command in a very structured way. So this is the advantage of the fully distributed mode. Now, moving on to question number 5, it states, what are the operating systems on which Hadoop works? Hadoop supports a lot of operating systems. In fact, it's an open source tool, and the support for multiple operating systems were being added one after the other. It's mostly preferred to use Hadoop with Windows or Linux because most of us almost use Windows or Linux, right? But then for the people who are using OS X, for the people who are using Apple's operating system, or let's say even the BSD, which is also called as the Berkeley Software Design OS, the support for Hadoop is there. So there is a lot of flexibility in terms of what operating system can be used to run Hadoop effectively. So make sure to mention 3 or 4 of these when asked. Coming to question number 6, it states, what is distributed cache? What are its benefits? Distributed cache, right, in Hadoop is actually a service. So what it does, as the name suggests, it caches files whenever we require it. So let's say there is a file which is cached for a particular job. What Hadoop does is that it will make it available to the data node, both in the system memory and both in the actual system where it's been accessed from, and of course in the memory as well. Because at the end of the day, this is where your map operations are happening. This is where your reduction tasks are happening, right? So if you have a cached version there, it's almost like copying it and keeping a temporary sample there where you can use it. You can populate any collection that you like, right? So think about arrays, think about hash maps, and all of that in your code, and later use it quickly without having to wait for the pull operation from another node. So what are the benefits of doing this? One benefit is that it provides a very simple path of you accessing the data, copying the text file, data file, or whatever it is. And it also ensures that there is developer efficiency in terms of there is a decrease in terms of access time. And of course, what distributed cache does is that it tracks the modification timestamp for each and every cache file, which means that the user or the machine or the language itself can have the capability to check if the file has been modified or not. So the general practice is that the file will not be modified until the job is complete, because once the file is changed, it doesn't become a cache file, it becomes a standalone file at the end of the day, because caching is a copy of something. Once you've copied onto that, it has to remain the same until you work with it, right? So these are some of the benefits and the working of the distributed cache in Hadoop. Coming to question number 7, this is a big one. It says, explain the differences between NameNode, checkpoint NameNode, and backup node. Well, let us check out NameNode first. I think you would already know this. NameNode is one of the most important components, the core components of the Hadoop file system, which is used to handle metadata. Metadata is what we talk about when we have to describe the events of files. See, files will have certain information, but then to describe what information these files has, that is exactly what metadata is. So what we're doing with NameNode is that we're trying to map all of these files using metadata to check where the block locations are, what blocks are located on which point in the data node, right? So what we're trying to do here is we're trying to understand and map a way on which, think about a tree structure, right? Think about a directory structure where we have all the files arranged one after the other in the Hadoop cluster. That's the exact purpose of the NameNode. So to do that, we'll actually require two files. One, we have the fsimage file. It's used to check the latest checkpoint of the namespace, and of course we have the edits file. Edits file will give you a log of changes that has been made after the checkpoint has been achieved for every single namespace entry, because at the end of the day, whatever changes you do, minor or major, it is very, very important that you keep it in check. This is NameNode. Now let's talk about checkpoint NameNode. Checkpoint NameNode is basically very similar to what NameNode does, and here what we're trying to do is we're trying to create checkpoints for NameNodes at regular intervals rather than in randomness. And here, by doing this, what we have to do is we have to download the FS image, we have to edit all the files, and later after editing, what we'll do is we'll merge these files into the local directory. And after this, we'll have a new image, and the new image, after being merged, is basically uploaded to the NameNode. So after these checkpoints, after analyzing them, after editing the files, after merging them, is when we create it and upload it to the NameNode. So this is the checkpoint NameNode. And then now when we talk about backup node, right? So backup node basically provides the functionalities very similar to checkpoint, but at the end of the day here, what we're trying to do is we're trying to achieve a synchronization with the particular NameNode. It is very vital, as I've been saying, that your file should be up to date. Your file should have an in-memory copy. It should not differentiate from each other when it's being cached or when it's a copy or anything like that. So backup node needs to save the current state in the memory to an image file, to create a latest checkpoint file as well. So this is what a backup node is. So this is the basic difference that lies in between NameNode, the checkpoint NameNode, and the backup node. So when you ask this, make sure to put the answer out in a clear and a concise way. And whenever you're answering questions regarding nodes, NameNodes, and especially data nodes, things get a little messy, right? Make sure you put the answer out in a very structured way. Now coming to question number 8, it states, what are the most common input formats in Hadoop? Well, there are 3 common input formats in Hadoop that you should know about. One is the text input, we have the key value input, and of course we have the sequence file input. So the default mode, right? So you can have another question here that says, what is the default input format in Hadoop? It's actually the text input format that is the default format. And then we have the key value input. So the key value input format is used for plain text files where the files are actually broken down into lines and later used. But in the case of sequence file input, here we make use of this particular format to read all the files in a particular sequence as per requirement. So these are the 3 common input formats in Hadoop, and you have to stay in order. Really doesn't matter. The default one is the text input, and talk about key value inputs, and of course how you'll be reading files in a sequence using the sequence file input as well. So with this, we can come to question number 9 that states, define data node. How does NameNode tackle the data node failures? Well, the NameNode we've already seen, right? But what is DataNode? DataNode is where the data actually gets stored in the Hadoop file system. The data actually resides here in a way where it has the capability to communicate with the NameNode. It does this by sending a message called as the heartbeat message. The heartbeat message literally, is to show that it is alive and that it is working. So what happens is that we have 10-minute intervals, and in these 10 minutes, if the NameNode does not receive a message from the DataNode, right? So the NameNode is waiting for the DataNode to send a message. In 10 minutes, if it doesn't send a message, what the NameNode thinks is that the DataNode is either dead or it's out of place or it's not working fine. And the NameNode actually starts replicating the blocks which are hosted on that particular DataNode which wasn't responding. And it takes that and pushes it onto another DataNode to make sure that the data replication and data redundancy part of it is maintained well as well. So this is how actually NameNode tackles DataNode failures. But then to denote the failure, we have something called as a block report. A block report is actually consisting of all of the lists of blocks that are present on a data node. So whenever a system starts to replicate it, right, you will get to know what data was stored in the data node and what data needs to be moved. So this replication of data to moving from one data node directly into the other by keeping a track under the name node by making use of a heartbeat message, this is something which is very important, and this is how communication happens between the data node and the name node. With this, we can come to question number 10 that states, what are the core methods of a reducer? Well, there are three core methods, whenever you're talking about a reducer. One is the setup, we have the setup method, we have the reduce method, and of course, we have the cleanup method. Talking about setup method is basically used to configure all the parameters that we have to feed into the network. See, you have the input data size, you have the distributed cache, and all of these parameters, right? So to do this, you can use public void setup and context as the parameters to send it in. But then when you talk about reduce is the most important part of the reducer, right? As the name says, it is the heart of the reducer. So every time there is a new key that's generated, the reducer is called once with that particular task. The key is given to it, the value and the context is added where this method can run the reduction operation and be done with it as well. And then when you're talking about the cleanup method, as the name suggests, again, is pretty simple. It is used to clean all the temporary files once a task is ended. So you will have certain files which are required to perform the reduction operations, but then as soon as the operation is done, you will not require them anymore. So in that particular case, it is vital that you keep cleaning the memory then and there to keep it effective, right? Cleanup method does just that. Now, do take a look at the syntax. And if you have a pen and paper in front of you or your computer in front of you, do make sure to put that down to showcase to the interviewer that you actually have worked on this or that you know it in detail. Now, coming to question number 11, it states, what is a sequence file in Hadoop? A sequence file is basically a flat file, in Hadoop. So whenever we're talking about flat files, especially here in the case of sequence file, it contains binary key value pairs. And, we have the map inputs, we have the map outputs, where the map output actually gets stored, as a sequence file internally here itself. So if you're thinking about what classes does this sequence file provide, it provides you the sorter class, reader class, writer class, and each of these file formats, right? So there's actually three formats that you need to know about. One is the uncompressed key value records. Then we have the record compressed key value records where only the values get compressed. And then you have the block compressed key value records where, it's not just values here, but both the key and the value gets collected in separate blocks and compressed. And the size of these blocks, right, this is assignable to you. So having it uncompressed, compressing only the values, or compressing both key and value in the case of sequence files are very important. So these three classes in the binary key value pair, see a lot of usage in the daily world. So it is very vital that you answer this like that. Next, coming to the 12th question, it states, what is the role of a job tracker in Hadoop? JobTracker, as the name suggests, again, its main function here in Hadoop is to basically handle resource management. So we have something called as task trackers, where the JobTracker actually handles and manages the task trackers. So it will be checking for resource availability, it will be checking for task lifecycle management, it will be understanding about what's going on in terms of fault tolerance, in terms of the task progress, and much more. So there's a lot of things that the JobTracker does in Hadoop, right? So it is basically a process that runs on a separate node and not on a data node. And this is a very important point that you're supposed to mention. And then of course the job tracker communicates with the name node to identify the data location. And if it finds the data, then it will execute the task. If it cannot find the data, then of course it goes into redundancy. But then one important thing is that it will monitor all the individual task trackers and submit your overall job back to the client. It's like, hey, it takes in all the data, it works with it, executes all the tasks, and sends it back in a structured way. So what it does is that it also tracks the execution of the MapReduce workloads, the operation, and the tasks local to that particular slave node, and creates a file where you can track that as well. So in terms of what JobTracker does, is it does a lot of things and it does them very effectively. That's the important part here. Coming to question number 13, it states, what is the use of RecordReader in Hadoop? So when you think about it, we have input split, right? So input split basically defines a slice of data, but then what it does not do is that it does not describe how to access this slice of data, right? So what the record reader does is here is where this class comes into the picture. Here we take the byte oriented data from its source, we directly convert it into the record oriented pairs, right? So you already know it, it's the key value pair. And after we convert the byte oriented data into its key value oriented data, then we give it to the mapper, where the mapper can handle the task, it can read it and work with it. So in the background, what happens is that the input format, right, it actually defines the Hadoop record reader instance where it keeps adding up onto that list about what's going on, what files got converted, and if the mapper is ready to pick it up or not. So in that particular case, even record reader adds a lot of value to Hadoop. Now, coming on to the 14th question, it says, what is speculative execution in Hadoop? Well, one important limitation we have to talk about every time we discuss about Hadoop is that whenever you're distributing a lot of tasks on multiple nodes, right? Sometimes it is not always that you have nodes which are really fast. So a few slow nodes will actually limit the execution, it'll limit the efficiency of the entire program, right? So when you think about it, there might be multiple reasons of why a task is slow. In a small scenario, this is a very simple thing to find, and you can work with it, hunt for the node which is slow and replace it. But when you're thinking about a large scale solution, it is not easy to detect which node is slow. So what we try to do here is, instead of fixing all of these slow running tasks, Hadoop will actually try to detect what tasks run slower than an expected time. It'll have an expected time through which the task has to finish. It'll see what task is taking more time than the expected time, and it launches other tasks as a backup in case if this is taking more time. So this backup mechanism that exists in Hadoop, right, this is exactly what we call as speculative execution. This is a very important thing to maintain high efficiency throughout the execution of our task, getting closer to our big data handling goals or whatever it is. Speculative execution is definitely one of the most important things that's adding a lot of value in the community of distributed computing. So when you ask this question, make sure to give it out in a concise way. Coming to the 15th question, it says, what happens if you try to run a Hadoop job with an output directory that is already present? Well, if your directory is already present, what Hadoop does, it's a very simple thing. It'll give you an exception saying it already exists, because you really cannot create a directory when already one is created, right? So a Hadoop job requires either a creation of brand new directory or working with it as well. So in that particular case, to run a MapReduce job, you need to make sure that the Hadoop directory will not exist, because if it does, it will not work. It will give you an exception. So in case if it exists, but then you want to delete it, run your Hadoop job fresh, make sure to use the file structure command Hadoop FS RMR, which will basically remove it, put the path to your output, and as soon as you're done with it, you will delete a directory, or you can make use of a Java API as well. Get local conf.delete will actually make sure that your directory gets deleted, and later as soon as you run the job again, this time you will not have an exception, but this time the job will run as expected. Now, coming to question number 16, it states, how can you debug Hadoop code? See, to debug Hadoop code, one very important step you always have to check is to check the list of the MapReduce jobs that are currently running. And once you see the logs, once you see all the jobs that are being run, there you have to make sure that there are no orphan jobs which are running. If they're running, make sure find the location of the RM logs, make sure to check it out, and especially when you run the command that's given on your screen, right, with the resource manager. So what it does, it will look for the log directory. It is very important that there should be no orphan jobs running. So based on what we find on the RM logs, right, we have to check if the worker node was involved in the execution of task or not. To do that, we have to log into that particular node, right? Because without logging into that node, we cannot see if a worker node was involved in the execution of a task. To do that, you can use PSEF grep inode manager, and using this, you can log into the node to see if it is the worker node that was involved. So later, after doing this, what you'll actually do is examine the node manager log, where the majority of the user level logs come from here, for every single MapReduce job out there. So this is a structured way, an ordered way of how you can simplify and debug Hadoop code. If you have a Hadoop structure running on your machine, if you have a standalone structure, or let's say if you're connected to a multi-node structure as well, open up your laptops to show all the working of this practically to the interviewer. That will add a lot of value to your candidature at that particular company. Not just this question, among all the questions we discussed, wherever it is possible, do show it practically. So with that, we can come to question number 17 that states how to configure replication factor in HDFS. See, to configure HDFS, you remember we spoke about 3 files, and one of those files are HDFS site.xml, right? So this is a very important file which we use to configure the file system. So basically, to change and configure the replication factor, we have the dfs.replication property that's present in this particular file. So by changing that, we can modify it. But then if you change it on a file basis, right, per file basis, where you're checking out each and every individual file and working with it, for that you have a Hadoop shell command, Hadoop setrep, where you can put in the file name and work with it. But then if you have to change the replication factor of all the files at a time, but then not like each one of them individually, then of course we have another Hadoop command for that as well. There are certain subtle differences. You have the capital R in the second one that denotes that you'll be adjusting the replication factor for all the files in the directory, and of course for the first one it's only the individual file. So here it's very important that you talk about replication factors on individual files, and of course replication factor changing on all the files that are present in a single directory as well. So make sure to mention this. Moving on to the 18th question, it states how to compress a mapper output, not touching the reducer output. To basically compress a mapper output which is not in touch in the reduction process, what we try to do is we set 2 things. To achieve the compression, we have conf.set, where we're trying to set the output compressed to be true, and what we're trying to do is we're trying to keep the file output format to be false. So after setting these 2 parameters, right, this is how compression can be achieved. It's a simple question, it's a very straightforward answer, and again, if you have a pen and paper, rather than spelling it out, make sure to write it down and show that you'll be setting the bits to be true in the case of the map output, but in case of the file output format, we'll be putting it to false. Now, coming to the 19th question, it states what is the difference between map side join and reduce side join? Well, map side join happens at the map side, right, as the name suggests. So whenever your data reaches the map, this is where the join operation takes place. So then, I'm sure you're already aware of this, but then to do this, you will really have to have a strict structure, right? So especially when you're defining your map side joins, you really need that. But then when we talk about the reduce side joins, it's also called as the repartition joins. So here, it's a little simpler when you compare it to map side joins, because here all we're trying to do is, map the files rather than the input data sets. The input data sets need not be structured out here. So when it comes to that, but then when you talk about efficiency, right, map side joins are more efficient here, because in the case of reduce side joins, it'll have to go through a lot of sorting phases. It'll have to go through a lot of shuffle phases where, you'll be coming in touch with a lot of network heads, and it might take a lot of time and, work power to actually get the job done in the case of the reduce side joins as well. So hence, this is one of the reasons why people prefer the map side join. But then to do that, you need the structure, and this is a very important point that you should talk about. Now with this, let's come to the 20th question that states how can you transfer data from Hive to HDFS? Well, it's a very simple question with a very simple answer. You just have one query that you have to write where you can pick up the data from your Hive and push it onto your HDFS. It's a Hive command as insert override directory, where you have the / select star from emp, where emp is the directory, where emp is actually the record there, and after you execute this query, you can import whatever files you want from Hive to HDFS. So the output that we get here is actually stored in part files in the specified Hadoop file system structure as well. So that's one very important thing too. So if you're expecting a very complex process of transferring files from Hive to HDFS, well, sorry to disappoint you, because it is pretty simple, as you can see on the screen. Coming to question number 1, it states what companies make use of Hadoop? Well, there is a lot of companies that make use of Hadoop. In fact, there's thousands of companies right now making use of Hadoop, even when you're watching this particular video. The big boys are Yahoo and Facebook, because Facebook developed Hive to perform analytics, and we have Yahoo is one of the biggest contributors in the entire creation of Hadoop. We have Amazon, we have Netflix, we have Adobe, we have eBay, we have Spotify, we have Twitter, we have a lot of other companies where each of these products have one particular or multiple use for Hadoop. So it can be a very small scale solution that they're trying to implement, or in fact it can be a very huge thing that they're trying to add on to their company by making use of Hadoop as well. So in that particular case, right, Hadoop is very, very well regarded and used a lot in many companies out there today. So question number 22 states, how do you stay up to date with the new and upcoming concepts in big data? So the 22nd question states, how do you stay up to date with the new and the upcoming concepts in big data? You have to know one thing is that this is a very commonly asked question here, because with this, right, the interviewer wants to understand what your interest is, where your interest lies, and what are your abilities of learning something new and how can you learn it well. So talk about how you've learned things in the past, talk about how you're planning to use these past learnings. Probably you could have taken an easier way to learn, a more structured way to learn, or there are many other concepts which keep coming out, right? So the tool of today will become obsolete tomorrow, and it is very vital that you know the latest versions of the software, you know what are the changes that happen. And it's not only that, it's about how you change yourself with these new changes, or how you plan to impart these new changes in a very simple way, in a fashionable way in your particular project of whatever you're handling. So the interviewer wants to understand this. He or she wants to understand your interest, your ability to actually find, and how you will learn new things, because in a production environment, when you're looking for a job, it becomes very vital that you have to pace yourself and learn new things rapidly. So make sure to keep this answer concise, but then put it out in a clear way. If you have a path, it can be very different from what I told you. You might go on the internet, check a couple of YouTube videos, pick up a certification program, or whatever it is. You really have to mention your way on how you plan to learn new things. As an added bonus, talk about how you've used these new things as well. Coming to the 23rd question, if you're a fresher, or if you're an intermediate user, or let's say if you're an advanced developer, there's a good chance this question is asked. It's a very frequent one. Hadoop is used in multiple different kinds of. So Hadoop is used in multiple industries, right? So you might be working at Facebook, which is a social media company. There's many other companies, right? There's Google, there's Yahoo, and there's Adobe, which do a lot of different things compared to social media. So based on the industry that you've worked in before, if you're a fresher, of course, you can say you're a fresher, and you'll move on to the next question. But then if you're an intermediate developer, who's looking forward for this interview, if you've had any experience in that industry, right? So make sure to elaborate about it. Talk about the industry experience that you have, because at the end of the day, you can talk about the tools you've used, you can talk about the techniques that you've used, and how you've made a change in the same industry before, and basically what you bring to the table as well. So it is very important, if you have the industry, do talk about it. But then if you do not have it, talk about how you plan to bring the learning from the industry that you belong to into this particular one. So you might be moving from social media to another industry, but then talk about how you plan to make that switch of what you'll carry along with you from that different industry, to see to it that if it works or not, or how better it can be implemented in this particular industry as well. So this is a very important question. And then the 24th question says, what is your plan after joining for the Hadoop developers role? Well, the first thing you have to talk about is when you ask for any plans in the future, right? So talk about how you're planning to understanding the complete data workflow setup in the company, because once you understand the workflow of the company, then you can have a plan of action. You can work on the plan of action, discuss it, implement it, and verify it to see if it's working or not. Don't just say that you're going to step into the company and start changing things around, because that definitely wouldn't work in a production environment. So you yourself have to get very familiar with what's going on, what's already existing, and then you can work on seeing what can be changed, what can be made better, or in fact, if you fit into the actual requirement that is already there, and you will not have to change anything. So in multiple cases like that, it is very vital that you state out a plan of action, right? You joining, you learning new things, you talking to the people who have done it, see what can be done better, verifying if it can actually be done better, and doing it better. So this is something that would add a lot of meaning to your particular interview as well. So with this, we can come to the last question, the 25th question, that says, have you earned any sort of certification to improve your learning and implementation process? Well, I'm sure if you're at this point of time, if you're at the 25th question, you will already know the value of what a certification program would bring to you, right? So you will have a lot of experts teaching you a lot of content over a couple of months. You'll be picking up industry level projects. You'll be working on real-time projects. You'll be given thorough training where basically you have learned all the concepts thoroughly. A good certification program will also give you industry level projects where you can actually implement your learning to see and verify if you have actually learned, because at the end of the day what you put on your resume is your projects, right? So if you put on a certification, well, it's well and good, but in an interview, as soon as they talk about the certification, the first thing the interviewer is going to ask is what did you learn and how have you solved problems using that? Because when you think about it, all the IT problems that exist out there today, right, are being solved and we have solutions for that. See, the entire process of big data handling itself is a problem, and handling that is the solution, right? So we had a lot of data that's being generated every day, and now we know how to handle it and work with it. In fact, that is one thing that you could state about what you learned in that particular program, but then make sure to elaborate about how you've learned it and how you've planned to use it in the near future, or how you already used it in the past to solve a real life problem. So all of these will give the interviewer an impression that you are very good at advancing your career, that you've put in your time, your money, your effort into working on Hadoop or working on big data. In fact, it also shows that you are an effective learner and that you have strong aspiration to pick up a certification program, to learn to it, to see through it thoroughly and become an expert at the end of it as well. So a certification program adds a lot of value to you as well as the interviewer, because all of that, the knowledge that you carry is very important for the company there as well. So in terms of job prospects, in terms of impressing the interviewer, in terms of working well at the job that you do, anything, right, a certification program definitely helps. So with this, we come to the end of the top Hadoop interview questions set. I take this opportunity to wish you guys all the very best for all the interviews out there. You can use this as a guide to see how you can approach each of these questions in an effective way, and how you can answer them in a clear and a concise way too. So with this, I wish you all the best, and I'll see you on the next one.
So I hope this session was very informative for you all, and that you took away a good chunk of information on how to ace your Hadoop interview. Well, with this, if you have any comments, head down to the comment section and do let us know. We'll be more than happy to help you out. All right, we'll see you on the next one.